All right, everybody, welcome to Earth Science. It's lab time. This is actually a double lab, which we do a couple of this year. One, two, three, four, five. Where there's enough to kind of make two labs out of it, and it counts twice in the gradebook too. So more points, more work, but more points. There's also one triple. We got that to look forward to. So as you're doing this, the first part here is density of solids, and you should have already watched a video about how to go get that stuff and get the joule beam balance safely and all of that. You'll work on all of this. And then here it says density of liquids. That's a separate lab. On the survival guide, there will be a separate video where I'll cover some of this and what you're going to do there. So I think it's pretty straightforward. I don't have to talk a lot here. I think you're going to jump right in and be fine. A couple important points that we've already covered in the notes. And if, again, do this in order. If you haven't done the notes first and you're jumping around, it's really going to get hectic quick, especially when this course gets harder. Water has a density of 1 gram per milliliter, or since 1 cubic centimeter and 1 milliliter are the same thing by definition, water also has a density of 1 gram per cubic centimeter. The same material should always have the same density. That's the galena idea. This galena here has the density that's listed in the reference tables. I've already forgotten. And every other piece of galena in every other earth science classroom in the state has a density that's the same, 7.6. Volume is length times width times height. So for this object, that's object. I don't mind if you say this one's number 1 and this one's number 2, or this one's number 1 and this one's number 2, whatever works for you. These are objects 1 and 2 in whatever order you choose. But since they're rectangular prisms, since they're measurable with a ruler, we'll do length times width times height for those to get the volume. Volume is length times width times height. If you do that in centimeters, your result for volume is in cubic centimeters. Centimeters times centimeters times centimeters is centimeters cubed. So that's objects 1 and 2, the rectangular things. Objects 3, 4, 5, and again, in whatever order you choose, are these cylinders, okay? These will do that displacement method. So you're going to have to get some water. You can either go back and forth with the sink, or you can grab a couple of beakers out of the cabinets over there and put some water in. Again, carefully put it at an angle, slide it down so that you don't blow the bottom out of this graduated cylinder and you don't splash the water out. And see how much the water goes up by. If it's at 50 and it goes to 70, that was 20 milliliters of difference. Hey, Mr. F, these all look about the same. So if I do it once, I can just count those, right? No. You want to practice safe science. Each one might have little individual variables that maybe it's off by a milliliter. Maybe that matters. Okay, don't be lazy. Check all 3. You'll be good. Mass for both of these, for all 5 objects, we'll be using the joule beam balance that you should have already gotten safely using 2 hands at your desk. Yeah? And then density is mass over volume. So I know it looks funny here. You got to do mass over volume, mass over volume. Maybe I could have done that chart better, but I didn't. And the reason I didn't was that I wanted you to do length times width times height is volume. So then mass over volume equals density. The 2 bars are same material, so what should their densities be compared to each other? Just like I've said many times with this galena. One of the 3 cylinders is also that same stuff. So which one of the 3 cylinders is probably the same material as those 2 cubes? And if I took something and cut it in half, what happens to their density? You guys know that. This is a Regents question. Use page 15 of the ESRT. It's planet data, which we're actually going to be getting into soon anyway, so this isn't really jumping forward too much. But here is the sun, the moon, and our 8 planets, and all of the info about them. Today's lab only is going to ask you about the density, so you'll only need that stuff. Another basic density problem, these are all Regents questions, so this is like a little bit more wordy. It tells you what's going on here with gypsum and a slurry, and you can figure it out if you know your density. And then lastly, this is going back to the ice cube thing, which was the first thing you looked at in this whole lesson, and now we're at the last thing. I guess not the last, because you got to do liquids here in a minute. But we're wrapping it up. So what's up with that? What's up with the idea of what happened in that ice cube demo? And if you say, geez, I don't remember, that was days ago, there's the link right there. Check it out. And describe what happened, explain what you saw, including ideas of density. I want to hear some sciencey speak here, some sciencey sentences. Don't just tell me what happened and say, man, that's good. You know what I mean? Give me the reasons based on these ideas of density that we've learned, why that's true. All right. Excellent work, folks. Keep it up. Only density liquids to go when you're done with this big, long run through density. I appreciate it. Good luck.